this webinar today about Listec temperature sensor cable in tunnel, road and rail train tunnel application. Please switch off your microphones and cameras so we will have less noise and a better communication. To the topics, we are first having a look to the requirements of a tunnel fire detection system called TFD. Then we have a short look to fire standards and code of practice. Then I'll show you some principle of operation, how this sensor cable works. Then we are looking a little bit to the fire detection concept when we design this system for road and train tunnels. And finally also some references and conclusion. Maybe to myself, I'm working more than 30 years in the security business, especially in fire detection system. And one of the application is a little bit have a little bit more experience is exactly the road and tunnel application, where I was working for many years in a different region of the world. Otherwise, I'm responsible, the sales manager for the Latin America market. Well, let's start with the requirements of a tunnel fire detection for what is needed for this kind of application. Normally, when we talk about fire detection in road tunnel, is always as quick as possible. The system must be react very quickly because we know the risk in a tunnel. Of course, the protection goal is first of all personal security. Always when we talk about fire detection system, personal security is first priority. And then of course also we have the infrastructure protection. This is also important in a tunnel. As faster we can detect, faster we can also control the fire, and probably will have less damage in a tunnel if everything works well. Then also the question is sometimes how as quick as possible, but that means yes, but we should also try to avoid false alarm. We cannot only be very fast, but we have to be fast under the conditions that we have in a tunnel. So false alarm are really not requested because false alarms are normally always causes a lot of queue by red light. So it could also be that there are collision accident when the tunnel is closing, especially when we have a traffic jam. So this is not really welcome when we have false alarms. So this is why we should try also to avoid false alarm. And also because delay of traffic, it's an impact directly in the economy when you're waiting hours, or delaying for hours to reach your office or home. Therefore, it's not really good to have false alarm, and waste of energy, of course, because imagine every time you have a false alarm, normally the system, the ventilation is starting to make the de-smoking inside the tunnel. That means everything is automized. So if there is a false alarm, you have to start this jet fan, and these are consuming a lot of energy to bring them to the maximum power and velocity, and therefore it's also a waste of energy, and this we have to avoid too. And finally, every time you have an alarm, automatically you are activated the fire brigades, the rescue team, because you never know is it really an alarm or not. And this is also like the motivation if fire brigades arrives and see there is no real alarm. It was only a false alarm. So therefore, it's possible to be very fast, but we have to be sure that we don't have any false alarm. Huh? And many tunnels today also have a extinguishing system inside the tunnels. They used to have in different sectors, like like to do a curtain, a water curtain, in order that the smoke is not passing from one sector to the other. And also here, in case of an alarm, you may trigger an extinguishing system, but it's actually involuntary. So according to the PRC, to the Permanent International Association, Road of Congress, it must be as fast as required. Today, I guess 1 or 2 false alarms per year may be tolerated from the operator. More than that, I think it's really critical. Well, then let's see the requirements for a fire alarm system in the road tunnels. This is a really special application. We are not talking about an application in a hotel, in a commercial building. This application has a lot of environment conditions that the system must be prepared and work under such extreme conditions. One of those are the emissions of diesel exhaust particles. Of course, here we have a lot of cars and trucks driving in the tunnel every day, and there is quite a high concentration of those kind of particles. Then also humidity is a topic. Depending on the localization of the tunnel, we may have higher or lower humidity during the day, in the night. So this is always changing because the tunnel is also open, so we have always air entering in, and this change of humidity may also be an impact of the different system installed in a tunnel. Then depending on the localization of the tunnel, we may have also a road salt mist, especially region where they have a winter with snow, and you have to prepare the roads again, avoiding ice on the roads. So normally salt mist is used, and this may also cause some damage to the equipments. Then we have the normal dust. At the end, we have causing from the cars entering in, also from the trucks, from the vehicles, and finally also from the wind, which is entering inside these tunnels. And cold and hotness, that means we have different temperature in the morning, in the afternoon, in the evening, between the different seasons. So we may have a lot of temperature changes. And this also must be considered when you choose the fire detection system for road tunnel. Then there are some additional requirements like system integration. It's important that the system can be integrated. Normally every tunnel has a SCADA system. It's a supervision system where they control all the electrical and the mechanical equipments. Therefore, it must be easy to be integrated. Then also the planning, the installation and commissioning must be, of course, easy. Usually the fire detection system is one of the last systems that you install in the tunnel when everything is finished. So it may very fast in the installation, and you also need to commission the system in a short time. Low maintenance costs. This is also an important topic due to the access. You cannot just stop a tunnel, close a tunnel, because you need to make maintenance on the cable. That means if you have a low maintenance system, this is a big benefit for the operator. And of course, at the end, the price is always an important topic that must fit in the budget if you see the complete electrical and mechanical system inside the tunnel. Then there is also a requirement for railway tunnels or metro tunnels. Most of them are similar, but here we have also different conditions. If we are looking, wind is of course a topic. We have train entering with speed in a tunnel, and this will increase additional the wind inside, the piston effect we have inside the tunnel. We have metallic dust due to the railway tracks when the train is breaking down also. So a lot of metallic dust in the air is can also cause some problem to a system. Huh? Then we have the electrical field, that electromagnetic field, which is caused by the power cable, where usually is used 16,000, 24,000 volts inside the tunnels. And so the system must also be immune to this kind of electromagnetic field. Then it's also considered a high risk area if you have to access inside the tunnel because of the train with high speed coming in, because we have power lines. So it's not very easy to access, and therefore the system, if it has a possibility to get a remote access and do some remote maintenance, that would be really preferred. Then the same thing also as in the road tunnel, we have different changes of temperature. Usually the tunnels in the railway sector are longer, and so we have a cold maybe temperature at the beginning of the tunnel, and in the middle of the tunnel we may have 20 degrees of difference from the entrance as from the middle of the tunnel. This kind of temperature must also be considered when you plan the fire detection system. The additional requirements are practically the same as in a road tunnel: system integration, easy installation, low maintenance, and of course also the price. Let's have a look now to the fire standards and code of practice. Just to give you a little bit a general overview. Of course, we don't have time to go very deep in every requirements, but when we are talking about fire standards, especially in road tunnels, I just listed some of the standards that are very common and that also are used as a reference worldwide. The German RABT standards, then the standard from Switzerland, also considering that Switzerland is one of the country with most road tunnels kilometers in the world. If I'm right, it should be more than 400 or 500 kilometers of tunnels. So those standards are also used worldwide. We have also the same standards in Austria, due also to the numbers of tunnels. Then the European norm, which is the technical norm for the fire detection, linear fire detection system, how they are built and how they are also tested. Then Brazil has also his own standards, and of course also the NFPA standards, which is also used worldwide for tunnel safety. Then if we are talking about train and metro tunnels, we have also here different national standards, but also a lot of code of practice, which if you don't have a standard or a norm, many of those countries maybe are following some code of practice. United States, we have also in Europe a lot of code of practice, but also in the Pacific region. Here we have also an interesting documents from Securiton, which are the design guide. We have a design guide for road and rail tunnels, which I really suggest that you can download this. You can access our webpage and register it, and then you have access to this design guide. In the design guide, you will find a lot of information about all these standards and the norm, which helps you to design also a fire detection system in rail or road tunnels. Then when we are talking about standards, what kind of speed is required in a tunnel? How fast must the fire detection system react if there is a fire? Of course, the standards are specifying how you do the tests and how fast you have to detect. I'll just show you a short video that you get an idea. If we don't react very fast, it's really a big problem, because you see how fast the smoke, when there is a fire inside a tunnel, is expanding. This video shows fire brigades doing some tests. We will see now this test is according the local requirements. Usually it's a test done with 10 to 20 liters of petrol. And you see how fast the smoke is going up and is expanding. The fire detection system is not triggering an alarm. That means the ventilation system did not start the de-smoking. And you see in a few seconds, there's no visibility. Even the cameraman you see, was also surprised that they are used to do fire tests in tunnels, but he was surprised that the smoke came down very quickly. If this fire detection system is triggering an alarm very fast, that means you can start the de-smoking, or you can accelerate the ventilator in order to push the smoke outside the tunnel and to keep it mostly high. Because the biggest problem is when the smoke is coming down and this tunnel is full of cars, it's very difficult to get out and find the escape route. And mostly, according to the statistic, if there are some victims during a fire accident in a tunnel, most of the victims are due to intoxication. It's not because of the heat. So the smoke is actually the biggest enemy in a fire inside the tunnels. So let's have a look maybe to 3 standards here. We have the German standards. They use quite a lot of petrol, 20 liters on 4 square meters. This will generate power of approximately 5 to 9 megawatt. 5 megawatt is when a passenger car is burning, like we see here on the picture. This kind of power is approximately 5 megawatt. Then we have 9 megawatt, could be also a little van or a little bus. So this is to have an idea what kind of power this fires generates. The only thing is then the norm is doing this test with quite a high speed. We are talking about 6 meters wind speed per second. And the requirements, the norm says that this kind of test must be detected in between 1 minute. So the system must be really fast to detect in less than 60 seconds under such condition. Even we have, let's say, quite a big energy during this fire test. You have to consider that the wind speed is also a very important factor. That means the temperature will increase, but will not increase so fast due to the wind speed. Then if we compare it to the Austrian norm, they use quite less diesel or spirit. They do it with less. And you see also here we have less energy during this fire test. It's going down to 1.5 or 2 megawatt. But on the other side, they use less wind speed and give a little bit more time to detect an alarm. So up to 90 seconds. This is because the fire is smaller, and so we have less power. Means we need a little bit more time to detect this temperature increase inside the tunnel. They do different tests. They do also with diesel mixed with petrol. So here we increase up to 3.5 megawatt. And also here we have 3 meters per second, where they also tolerate around 150 seconds to trigger an alarm. If we compare maybe to another region, which is Brazil, it has its own requirements. They use also very similar to the Austrian standards, mixed of 20-liter diesel mixed with 5 petrol. And also here they need to detect in less than 90 seconds. Let's see a little bit the principle of operation of this temperature sensor cable. If you can see, we have, it looks like a standard cable, but inside the cable we have different spacement where you can find the temperature sensor. This is embedded in the cable during the production. So you can have different intervals. You have from 1 meters, 2 meters, up to 10 meters. Usually when we use the cable for rail and road tunnels protection, 8 or 10 meters is enough. Usually 10 meters is the most standard distance we use. If we have an industrial application where you have sections where you have to use another spacement, you can use 1 or 2 meters. But also we can manufacture the cable customized in a distance you also need. Then we have the resolution, which is quite impressive. It's 0.1 degrees, so it's a really exact measurement of temperature we have. We have the aluminum protection inside, which gives a little bit stability in the cable, but on the other side it's a good conductor for the heat. So in case of a fire in a tunnel, the cable will heat up and the aluminum will help to conduct the heat to the several sensors we have close to this area where we have the warming up. Then a little bit an overview. We have two types of sensor cable. We call them SEC 15 and SEC 20. The difference is the SEC 15, it's a little bit thinner. It's like 15 millimeter diameters. And here we have a limited number of sensor. They are maximum 200 sensor, or we can reach maximum with this cable 700 meters. So it means you need one controller for 700 meters, but you can expand. You can have several controllers in the same tunnels and expand every 700 meters. Or you use the SEC 20, which can have with one controllers up to 3,500 meters. That's very interesting for middle and long tunnels. So you use less controllers and you have really the maximum capacity of 3,500 meters or 350 sensor if you use a distance every 10 meters. The measurement temperature range is normally from minus 40 degrees up to 120 with this kind of cable, or 200 degrees if you use the bigger cable. The operating temperature range is normally from minus 40 to up to 85 degrees. Then very important is the alarm evaluation, which we call the differential temperature alarm. 95% of all the alarms in a fire is always because of the increase of the temperature and not because we reached the maximum temperature. So the increase of temperature is very important because this will determine how fast we can react, or how fast the system has to react in case of a fire. We have here the reference value. We have the red here line, which is the actual temperature that we have at the moment, for example, in a tunnel. And then we have, during a fire, the differential value. This is the increase. And this here we can configure, we can decide how fast the system or the sensor has to detect. One example can be 0.5 degrees in 1 minute. So if we have these conditions, the system may trigger an alarm. And so we are able to program every sensor with a different value. Then all the sensors are reporting their temperature if they are connected by TCP Modbus to the SCADA system, and accurate information. The operator will see here, like on this graphic, the sensor number 1, sensor number 2, number 3. You see the exact temperature. Remember, with the resolution of 0.1 degrees. So the operator can really see what kind of temperature I have in different sectors. And this may be helpful because sometimes he has to trigger, or he has to slow down the ventilator, or if the temperature are very high in some sectors, he can also increase the velocity. But this is an information which is very important, because if you see that in one sector we have a high temperature, he may switch to the camera, he may also look to other devices and see what happened or why we have such temperature increase in different sector. Well, just resume of this temperature sensor cable. We have up to 350 sensors, so we can reach up to 3,500 meters with one controller. The system is rate of rise and maximal alarm, so we have two conditions. We can first condition determine how fast the system can react during increase of temperature, but we can also set a maximum temperature, which can be between -40 up to 85 degrees. This is also important that we have a setting of a maximal temperature. Then we have temperature values for each sensor available. So each sensor is reporting the real temperature to the operator. Then we have the possibility to have a redundant operation. I will show you later in the system design how we can do a redundant design. Derivation are also possible. The derivation is that when you install the cable in a tunnel, you can also do some derivation if you have to protect, let's say, different, it could be a platform in a metro station, but it could also be parking area inside the tunnel, or you also have to protect a gallery which makes the connection between two tubes. So this derivation can be done during the installation, but it also it's possible to do such derivation after you install the cable. So this is very flexible. Then a faulty sensor does not stop the system. This is also important to know. If there is a sensor which get damaged, it could be also that some way the cable was cut, or there was an accident, and during the accident maybe we have a few meters of cable that were damaged. That means that not all the system will stop. So we are isolating the few sensors that were damaged, but the rest of the sensors are working properly. This is also important to know that there is always a coverage of fire detection system, even we have a faulty sensor. Then we also have this already before, had operating temperature. It may also reach 200 degrees. This is not a problem for the cable. Of course, then if it's increasing by 200, 300, 400 degrees, there will be some damage on the cable, but then we have already a fire in the tunnel, and a lot of equipments must be exchanged when we have such high temperature. The resolution, then the detection of the infrared heat radiation. This is also very interesting. As we are using a physical temperature sensor inside the cable, they are very sensitive also to infrared heat detection. So that means if there is a truck standing inside the tunnel which has an overheated engine, it may also possible that this kind of radiation can be detected. Then the system is also fully protected against external influences, especially also electromagnetic influences in train tunnels, but also different kind of conditions, as we saw before, gases and dusts. So the sensor is really embedded in the cable, and therefore is no problem such under these conditions. And I think one of the most important things, the cable is maintenance free. So we don't need to do any maintenance on the cable. The sensor are communicated directly every 10 seconds with the controller, so we have to fully control that all the sensors are working. So there's no maintenance needed on that time. Let's see the fire detection concept in a road tunnel. When we have a control center, so obviously the control center is receiving different information, and one of the information are the cameras. Hundreds of cameras normally are installed in a road tunnel. There are also different kind of equipments. We have visibility monitoring detectors and also other kind of gas detectors for CO, for example, the air quality. So therefore, we got a lot of information in a tunnel. And of course, there is also the line type heat detectors. This is probably the most important system, because when we receive the alarm system, only then the system can trigger the ventilation, can trigger the fire light. That means has to put the fire light on red to avoid that other cars are entering in the tunnel. And at the same time also alerting the fire brigade. And if the tunnel is equipped with an extinguishing system, that means that if you have a second alarm, this extinguishing system will automatically be triggered. So people are operating the system normally, but when there is a fire alarm, this is all the triggering has normally an automatic sequence. So it does not depend on an operator. The operator can also trigger, of course, all these kind of equipments, and especially the ventilation, the traffic light. But this is also fully automatically integrated in case this does not happen. Then fire detection in road tunnels is important, that all the information is going to the SCADA system if it's available, because here we really get the temperature profile, and therefore the system must have this possibility to be integrated. First, because as I always repeat it again, the most important thing is as soon we trigger an alarm, we need to close the tunnels. You have the light signal that you can switch on red. You have the different panels before you entering to the tunnels where you can stop the traffic, because we really need to avoid that the cars are driving to the tunnels. First, because inside the tunnel may be a lot of smoke, and second, because we should not let other cars entering in, that the fire brigades has also the space to exceed the tunnels in order to be able to fight against the fire. Then also very important, the activation of the escape route, all the lighting that you have to trigger so that the people inside the tunnel can easily find the way out and protect themselves. And of course, the ventilation system has to be programmed to de-smoking, and therefore it's very important to bring out all the smoke to fire brigade. Then fire detection in train tunnels will happen normally if the train is burning. That means they have to drive to the next station. However, if you have tunnels, especially metro tunnels, you may have different train sections between 2 or 3 stations, and therefore it's important to have this kind of fire detection system, because you can control if there is a fire. And if there is a fire, you have also to give the signal to stop all the trains, because maybe one train which is on fire cannot go to the next station because the next station is already occupied by another train. So all this information for the operator are important to control the traffic in case of a fire. And this communication is also important because we use, normally the tunnel is used also for all the power cables we have. You see the power cable, normally they are installed on the side of the tunnel, some of them on the top. So this also causes a risk. It also may be a risk for a fire if there is some short circuit or some overheated cables, which is maybe the cause of a fire inside these tunnels. Then fire detection in road tunnels, which is also very interesting, is once we know we can detect a fire in a tunnel, maybe close to a station, if you are talking about a metro tunnel, we also need to evacuate the people that are waiting here on the platform. So therefore it's important that we also detect the fire inside the tunnel, because the smoke will come out of the tunnel and will be dangerous for all the people waiting on the platform. Huh? So therefore it's also need to trigger the ventilation to de-smoke. And then in addition, the temperature profile, if you have a system which is integrated in the SCADA system, you see the profile of the temperature. And if there is a train which is stopping here on the platform, we are also capable to detect some overheated engine. Huh? If the train is really passing very slow or will stop for a few seconds, normally the sensor cable will be installed on the lower part when we reach the platform, then it's going up again, and then it's continue on the roof. So during this period, because we can detect infrared radiation, it's possible to receive some information about overheat engine. Huh? This is also interesting, and so therefore this information is interesting for the operator. Then for that, I think we have the solution. This is our Listec temperature linear detector. Here again, maintenance-free, fast and reliable detection, precise localization, where exactly the fire was detected, in order that the fire brigade can reach the point, the exact point, and of the fire and control the fire. Huh? So let's see the system design of this list sensor cable. We have different possibility to do a design. Very simple design is you have one cable inside the tunnel. This is connected via communication cable to a list controller, and from the list controller you go first with some relay contact to a fire control panel in order to fulfill the local fire requirements in case of alarm. So you will get also an alarm on the control panel. On the other hand, you can integrate directly using Modbus TCP IP this list controller to the SCADA system, so that the operator is able to get the temperature profile of the tunnel. Then we have a redundant design called loop installation. Here we have, for example, two tubes, and you can see the linear heat detector cable is protecting the tunnel. And when it's coming back, there is one technical room where you can start the installation and come back again on the same controller. This loop installation will help that in case of an interruption in the sensor cable, you will not lose any communication. Huh? You will even not lose a sensor if there is only a cut between two sensors. So that means the system is still working 100%, and you can do some repair work maybe during the night, or when the access will be a little bit easier. Then you have the fully redundant system design. This is when we have two controllers. One possibility is you have a tunnel, then you start with one controller here, and when you end at the end of the tunnels, you will have in the last technical room a second controller. In this case, you not only have a redundance where we have an interruption of the cable, but we will also have a redundant in case one of these two controllers will fail. It can happen, and but even that will have always one controller taking the control of all the sensors. So this is it's a fully redundant design. This is what we normally always recommend when we do a design in a road or train tunnel, because in this case, even there is a sensor failure or there is a controller failure, the system will still work without any interruption. And maybe if you have the same configuration as we saw before with the loop installation, you can also, instead installing only one controller, you can open the loop and do installation with two controllers. So you have a redundant on the controllers and also on the cable. The installation of the sensor cable is very easy. Depends sometimes a little bit of the roof. If you have a regular roof or you have an irregular roof, you choose the right support accessories. And normally, as I said, the fire detection system is always one of the last systems to be installed. So it's actually very fast. If you have a good access, you install first all the clips and then you come behind and can install the cable. So we are on final of the presentation. I show you some references and the conclusion. I just took one or two references also from the region where I am responsible. This is a very interesting tunnel, not only because of more than 12 kilometer sensor cable, but the tunnel is situated under a city of Santiago in Chile. So there's a lot of traffic all the day, especially in the morning, in the evening. And this tunnel is also constructed under a river. So you have a problem of the infrastructure that you have to protect, but also you have always a lot of traffic jam. That means a lot of numbers of cars driving in, and therefore it's very important to have a very fast detection system. Then we have also in Brazil a success story, which is a highway with several tunnels which connects the city, near to the city from Sao Paulo to the coast. And here we have several tunnels, totally more than 26 kilometers of sensor cable are installed in those tunnels. Then also, must mention also these big projects here. The Gotthard Tunnel is considered one of the longest tunnels in the world with 17 kilometers. Also here, they trust fully on Listec sensor cable. And at the end also some tunnels in the Asia region. I just picked up one from Korea. Korea has also many tunnels protected using our technology. And here the Yangpyeongman tunnel, which is almost 8 kilometers, is also a very nice project. Finally, we have much more references. Today, more than 4,000 kilometers of sensor cable are installed worldwide, and more than 650 tunnels are protected by this technology. All of these metros has also this list cable, some of them to protect the tunnels, some of them to protect other areas like platforms, like mechanical stairways. So a lot of application using this sensor cable. Finally, conclusion, again, the fire detection system is a must for these tunnels. The line type heat detectors is we call them a catastrophe prevention system, because it's the only system who will trigger in case of an alarm. The ventilation, who will trigger the traffic light to avoid the cars entering in, and who will also trigger the escape route control. Therefore, it's a must to have fire detection inside the tunnels. And finally, to avoid this kind of accidents that we have in the past, and all we have learned about that, and therefore when you have a fire detection system in a tunnel, I think most of the accidents can be avoided or keep it on the minimum. This is my end. I will say thank you to everybody, and if you have some question, please let me know or write it in the chat, and we will be answering this question to you as soon as possible. Thank you very much for your attention.